Hello, everyone. Good morning, good afternoon, good evening to you from where you're joining us. Today, in this fine day, this is the Kish Foundation Public Teaching in English for Monday, November 6, 2017. And today is part 7 of the Understanding Plasma Science series. And today we're going to be covering topics of course, plasma science, nanocoating, and GANs. Of course, as usual, we have Jim and Lisa McDonald here, and Shander Kakashi is here also. So I'm your host, Flint Mulhausen. Welcome, everyone. Hello, Jim.
Hello, Flint. Hello to everybody. Yeah, we're halfway, so I suppose we have to say it's half full in terms of our progress on these workshops, and we do hope that you are enjoying them and it is making sense as we progress along this journey of trying to understand the plasma. I'm going to just share my screen. Can you see that, Flint?
Yes.
Okay. All right, so as Flint said, today we're doing a bit more on the science. It'll be a bit of a different angle we'll tackle today, still building on the knowledge that we have done over the last 3 parts when we've dealt with the plasma. The nano will be doing another method for the nano coating of your plates and how that is used. And then on GANs, we'll be looking specifically at the zinc. Okay, so this technology is brought to you by the Kish Foundation and Mr. Kish, who has brought this technology to us over the many, many years that we're all very grateful to be able to learn and understand how our world really operates around us. So we'll kick off with on the plasma science section. And today we're just going to have a look at how our planet creates life. So we've learned about the plasmas and the fields and the interaction. And so now I'm just going to go through how this interaction and bring it back home to us as to how life has been created on this planet that we're living on. So the process of life on this planet depends on one main factor, and that is the position of our Earth in relation to its position to the sun. And it's this interaction of the fields from the sun and the fields from the Earth which leads to the creation of the plasma of nitrogen in our upper atmosphere on this planet. So if we understand any changes to the magnetic fields of Earth or the sun, the position of the two is going to change this condition, and then we will have very different life on this planet than what we'd see today. So it all comes down to the positioning of the Earth and the sun, just like the positioning of the two magnets. So we have this interaction between the two plasmas, the plasma of the sun and the Earth, and it's this interaction of these fields which leads to that creation of the nitrogen for this planet. And here's just another slide just trying to illustrate the interaction of these two plasmas, the sun and the Earth. And also just bear in mind that we're just showing you the two interactions, but there's many more interactions going on with all the other planets around Earth. But for simple sake, we'll just show you the two interactions of the sun and the Earth. And we learned about the magnetic rays coming from the sun. And so these are the fields that are coming and interacting with Earth's magnetic gravitational fields. So when we look at the Sun-Earth interaction, it's the fields from the sun and the fields from the earth. And this interaction leads to the creation of nitrogen. When we look at other planets in our solar system, when we look at Jupiter, it's much further away from the sun. And so it has a different position in relation to the sun. And because of its position, it is mainly composed of hydrogen and helium that is created in its upper atmosphere due to the interaction of the fields from the sun and that planet. And it's the same for Saturn. So as you can see, it's just the positioning of the planet in relation to the sun, and it's the interaction of these fields which leads to the creation of nitrogen in the case of Earth, or in the case of Jupiter or Saturn, you're mainly getting hydrogen and helium. So when we have a look at closer look at nitrogen, now nitrogen has residuals, combinations, and divisions. So essentially nitrogen for this planet is the creator. So it's the nitrogen and the other fields from the sun interact, and due to the friction, it releases hydrogen or helium. So when we look at nitrogen losing fields, it can become carbon. And when we look at nitrogen gaining fields, it can become oxygen. So we can say that for this planet, from the interaction of the nitrogen, it leads to the creation of the carbon and oxygen are created from this mother nitrogen. And they all have a connection, and that's why they stay together. And the plasma of hydrogen is created out of this interaction as well. So it's the interaction between the nitrogen to carbon and nitrogen to oxygen, which is releasing additional fields, and this is the hydrogen. So in essence, what we have from that nitrogen, we have the creation of our carbons, oxygens, hydrogen, and nitrogen in the plasmatic form. And when we have these four elements in combination with the salt, leads to the creation of the amino acids. And that leads to the creation of beginning of the life on this planet. And as we know, we all composed of carbons, oxygens, nitrogens, and hydrogens. So when we have a look at the role that each one of them plays, we look at nitrogen as the creator. Oxygen plays the role of gravitational within their structure, and then carbon's a communicator, and it's a connection between all other amino acids and fields, and your hydrogen is the energy. So when we look at life on this planet, it's made up of endless combinations of the carbons, the oxygens, hydrogen, and nitrogen, which is your amino acids, and endless combinations in connection with the minerals. As you can see, when that comes in contact with iron, it leads to the creation of the human blood as we know it. And when these same amino acids come into contact with the magnesium, that leads to the blood of the plant. But it's all essentially from the same source. And so when we refresh and look at the breakdown of the elements of the plants and us as the humans, we can see that we are essentially 96% of carbons, oxygens, hydrogens, and nitrogens, whether it's the plant or the humans or animals. So it's just endless combinations of different amino acids. So when we try and break this down a bit further, when we have the amino acids and that comes into contact with the elements on Earth, say copper, that leads to the creation of our muscles. And in connection with the zinc, that leads to our creation of our emotion. And when we have the amino acids and iron, that leads to our blood. And it's the same for plants. When you have that amino acid in connection with the silicon, that creates the physical structure of your plant. And when you're in connection with magnesium, that's your sap or your blood of the plant. So when we take a step back and we look at the man and we look at the plants and the endless combinations of the amino acids with different minerals on this planet leads to the creation of different life. And here we've shown man and plants, but it's the same thing for earthworms and insects and bacteria. But we essentially have come from that same source of nitrogen, which led to the creation of the carbons, oxygens, hydrogens, and nitrogens. And when we take another step backwards, it's all essentially from the interaction of the fields between the sun and the earth. And so it's just this condition on planet Earth where we create the nitrogen from the interaction of the fields, and it's in combination with the different minerals on this planet leads to the creation of life as we see it around us today, be it man, plant, or bacteria. And so my little simple illustration here is just trying to put that, the bigger picture in your mind is that here on Earth, we have our plants and animals and other creatures, and it's this interaction at the boundary, the magnetosphere of our Earth, that we create the carbon, oxygen, hydrogen, and nitrogen. And it's how this combination interacts with the salts, creating the amino acids, and it's that interaction with different minerals, metals, leads to the creation of the life that we have on this planet. And it's this condition within which we are living. So we will have open for a few questions. If we can please just keep the questions related to the topic so that we don't go off topic.
Okay. Anybody have any questions here? You can always raise your hand.
See, Mark Erb had his hand up, and I promoted him to a panelist.
Thank you.
Jim, traditional scientists say that the sun is hydrogen. Is that somehow connected with all of this?
From what I've understood is that our universe is essentially the principal fields of hydrogen. And so from that leads to the creation of everything else.
So that would lead to the, that would help to create nitrogen and the constituents of the amino acids.
Yes. You know, it's these fields, and we've got to understand that it's in the interaction. We're creating certain conditions. You know, the distance of Earth in relation to the sun, that creates a certain condition which leads to these fields creating the nitrogen. And the life that we have on this planet. Somewhere else, you say on another planet in our solar system, because it's different position, will have different life on there in different conditions. So it's just our position of Earth has created the condition for life as we see it around us. And there's also many other life on this planet which we don't see. So
Jim, may I ask something? Jim, can you read me?
yes, I can hear you.
Good. We've been working with zinc and copper plates because we're working on man and human or animals. But if we work with silicone and magnesium, as you've been with the agriculture, could we go straight into the plant life? Or you haven't looked into this?
What do you mean goes into a plant life?
Well, on that sketch you had on just beforehand, the plants related to magnesium and silicone. So instead of working with zinc and copper, if we worked with, in some different way with these elements, we could deal with directly with the plants, I imagine so.
Well, yes, if you're going to be creating different ganses so that you find that connection with the plants, it's no use trying to make a gans of gold, for example, and try and interact with this with the plants when there is no connection in that plant there with you. So one has to find that right connection. Does that answer your question?
Yeah, well, I was looking at the periodic table. Magnesium is pretty far away from copper. We'd have to work with the numbers and see what could happen. But, well, yes, I imagine so. As you are in the agricultural part, you might have looked into this a bit further, but I imagine it's pretty difficult to work with magnesium. And although the magnesium plate, is it the one that if you take out of the water, it sort of consumes with the oxygen?
Can we just leave that question? Because it's not quite related.
No problem. Yeah, I didn't want to go this far, but
yeah.
Yes.
Any other questions there? Anything in the live stream, Rick? Facebook?
No, I don't see anything there yet.
All right. Well, I'll take it as a good sign. So. Loud and clear, yes. Okay. All right. So we'll move on to the next section. And we will continue down the road of nano layering, nano coating. Okay, so before we get going, in part 3, we introduced you to the hot caustic method of creating your nano layering on your copper. So today we're going to go into another method, just to refresh our memories on what that method was all about. It was sort of a hot caustic process where you're putting your plates into hot caustic, and it was sort of going through the drying stage and aligning your layers and leaving it there for two weeks to 2 months. So it's a very long process creating your layers. and washing your plates and then storing. So it's a very long process, but it creates, it's sort of the right method to create the nano layering on your copper that you are needing. So now we'll go into the next other method of doing it. And obviously beforehand, we need to look at your safety and personal protection, because when we're always dealing with caustic, and we have to be very, very careful. So always wear your gloves and glasses, and always have water available in case of little spillages and accidents. Right, so this method is the caustic steaming method. So first of all, we'll just have a look as to when to use this method. We don't use this method as our first nanocoating process. And I refer to, on Rick's plasma reactor group, there was a 3rd of January, where around the 2-hour and 42-minute mark, where Mr. Kish came in, and I urge a lot of people to go and back and watch that workshop where Mr. Kish comes in and really explains the different methods and why we have to go through the hot caustic method first and not do the steaming method first. So I do recommend that you do go back and watch that workshop there. So we essentially are only using this method, the caustic steam method, as an optional or secondary coating after we've had our 2 weeks or 2 months of curing, as per the hot caustic method. So essentially what we're using this method for is to renew any of our nano coating on already nano coated parts. So when we've been using our plates in producing the GANs, and we'd like to, a lot of the layers have sort of come off, and we'd like to recoat these plates that we've been using, then this is the method that one uses, is the caustic steam method. The caustic steam method used properly, it's a secondary coating. If we do it after the hot caustic method and we use this then method as the secondary coating, it will create very puffy layers of your nano layers with high porosity. So it's almost like a dust, and which can be better impregnated with various GANs materials for various purposes.
If I may add here a little thing, it's Sándor from Budapest, Hungary.
Please come in.
So when you use your nano-coated plates or wires to make some GANs material, you will observe after a time, maybe due to the salt water, the layers may be a little bit degraded. And if you want to renew it, if you would put them into a hot caustic bath, you would see that the thermal shock reaction would cause the sudden dilatation and later contraction of the plate, and the previously made layers would fall off. So that's why you cannot immerse again into hot caustic bath nano-coated part. But this caustic steam method, it's very good to refresh, to renew the coating on your plates. So some people got in confusion because they have been posted some years ago along with the instructions for use of the first CO2 kits. 2 videos made by Armin Guleran, 2 excellent videos, where he presented separately in 2 videos the 2 methods. But some people in their mind added together, they missed the explanation when to use which, and they just combined both. That first they made the caustic bath, and immediately in the next hour after the caustic bath, or the next day after the caustic bath, immediately they went to the steaming method. So, which is not the case. So first, you make a normal nano coating by immersion in caustic, and that process takes minimum 2 weeks, together with the conditioning, when you allow the growth of the layers. Optionally, you can continue with adding more layers by the steam, or you can use the steam method just to renew older coatings. So there are 2 cases when we use those. So short videos are very good for giving an image, but they will not substitute all the teachings which are related to the process.
Thank you, Sandra. I think that's where a lot of us have, including myself, we sort of have gone, we've misunderstood those videos. So,
yes. Also remember the first blueprint week from started in 2015, October 26th. It was a whole week of teachings regarding the blueprint. Why those teachings? Mr. Kish explained clearly, so we could release simply such a blueprint, some drawings with a short description, but that's not enough for people to be able to replicate something which involves a lot of knowledge. So that's why it was needed for additionally 1 week of explanation of the theory behind and individually the processes. So short versions are very good for memorizing something, to keep something in mind, but they will never substitute the entire teaching. So that was my point.
I have a question for you, Sandra.
Yes, Dr. Gatwa?
Yes, this is Gatwa, yes. When you nano-coat copper, for example, copper coils, over time they turn green. That is what I have noticed. So if you wash the green off, you have removed the nano layers.
So how you want to wash them off?
Well, if
because you cannot scrub, you cannot touch the surfaces once they are nano coated.
So that's the question. That's what I'm asking.
So let me explain why you get such a green or bluish things over the nano-coated surfaces. Once you created the nano-coating, already the layers will create some fields, and in certain conditions, it may be possible that they are picking up already some gans of copper. So that's gans of copper oxide which can appear. Another case when many of the nano-coated plates got blue or green was the case if there was some chlorine into the used water. So when the nano-coating process was done with tap water, for instance, which was chlorinated. So in all cases, we use distilled water for the best results, or filtered rainwater, which is distilled by nature. So basically, once you made the nano coating, you don't touch the nano coated surfaces because these are very fragile. You see, like if you have a cake which is very soft with a lot of cream on the top, you don't touch it. Same is with the nano coated surface.
So, in the case of well, go ahead, Gatua. I was just going to say, in the case of Gatua, you know, what could be done? Sorry, go ahead, Gatua.
Okay, thank you. The question is, Sandra. So it happens that we get that green, which looks exactly like the CuO gans.
Yes.
So what that means is that the nano-coated layers are not very firm, or somehow there is a exposure to the original copper. So now do we actually put that, I mean, into steam? And
You can do, but you can do, but whatever green color thing was added to it by the action of the fields, that stays there, that remains there, and that will be part of the formula. So if this appears often, so it's good to review your process and to find at which step it appears and in which condition.
So, but in case you get the green, so wouldn't the best thing to do be to clean it off and start the nano coating again, all over again with hot
Well,
caustic?
that's not a bad idea. That's not a bad idea. Another thing is how can you remove and clean the all nano coatings, which would not be the subject of today's presentation because we are in a limited time.
Okay, thank you very much.
You're welcome. So let's go to the caustic steam method after we clarified why and when we use it. So we never use the caustic steam method as the first process. Some people observed if they made a nano coating in a way that some parts of the copper were immersed into the water, into the hot caustic water, and some parts were above. Some people may have observed that those pieces of copper which are above the level of the hot caustic, those become instantly black. And some people got happy for, wow, it's a better condition to make it black faster. Yes, but that blackness, it's not of the quality we need. When we do the nano coating by immersion, we see that if we do correctly, the copper parts stay shiny metallic color until they are under the caustic. And only when we remove the caustic, they start to change their color slightly, and then they get black after a while when they create a sufficient number of layers. But that which you make instantly by steam, it's black, but it's not. It doesn't have the properties which we need, and this you will find out later when you try to use them. You will see the difference. But the caustic steam is very good. For instance, if you want to make a special nano coating, you do first the immersion method. And after at least 2 weeks, if you want to increase the layers, in that case, without washing them, you continue with the steam method and you wash at the end. So let's let Jim McDonald to present the part of the caustic steam method for nano coating.
Thanks, Sandor. All right, so as before, you need to prepare everything in advance because when you're dealing with the caustic, don't try and start halfway and then run around and trying to find all your other bits and pieces. So get everything prepared. And so you have your box with your chicken wire mesh at the bottom. And using your gloves that protective wear all the time, and try and only touch your plates or your copper components that you're trying to re-nano layer just at the edges, as little touching as possible, because every time you're handling, you are damaging those layers. So there's many methods, but one of these is just to fix a copper wire across your box, and so that you can actually hang your plates onto this wire, so that your plates, anything that you're wanting to nano coat, is hanging and not sitting on the base. And if you're going to have 2 or 3 plates, then you need to make sure that these plates are all hanging and they're also not touching each other. So nothing must touch each other in that box. And then you can add a sprinkling of your caustic soda and potassium hydroxide onto the bottom of the box. And it is best to actually do this before you start hanging any of your plates. so that you can get a nice even distribution, and then you're not having any caustic that might be falling and sitting onto your plate when you're pouring it in as well. And as before, we're going to add boiling water. And once you've added your boiling water, then you can close your lid. But now this time, we're only adding a small amount of water. And the water that we're adding in must not touch your plate. So we do not fill the box full with the water. We just fill enough on the bottom so that the water just fills the bottom of your container and doesn't come into contact with any of your plates or components that you are hanging in the box. So it essentially becomes just a pure steaming process, and there's no contact of that liquid caustic with any of your components. So once you've added your water, same as before, put the lid on and leave your box for 48 hours. And do not open the lid during this time. After that 48 hours, if you want to add more layers, you can then do this several times, depending on your application and what you're wanting to do. You can just add additional layers to your plates. And as before, we get to the conditioning process. So you also want to just pour out. If you've just got one plate, it becomes a bit easy, but you want to pour out most of the caustic that's in the bottom there. If you have a couple of plates in there, it's best to take the caustic out with a syringe, or there are many other devices on the market that one can use just to pump out, even a little hand pump to pump out your caustic from your box so that you're not disturbing your plates at all. So you just want to pour out your liquid and just to leave a small amount into that box as before. So as shown there, you're just leaving a tiny little amount so that you still have a small bit of your liquid caustic in the box. And then we go through that same process as before. During this drying time, you want to drain the voltage from the plates. So you use your multimeter and you place your electrodes on the opposite diagonal corners of your plate, or if you've got coils on either end of your coil. And this can be done every 6 hours in your first 24 hours after you've drained your caustic liquid. And we are using your multimeter. You will notice that you get your fluctuations of your millivolts on the meter. So this is normal. It fluctuates between your positive and your minus, and it just takes a few seconds. And as I said before, if you're looking at wires or coils or any of your pins, then you just apply the probes to the ends of the wires. Because the whole purpose of the voltmeter during the drying stage is to stabilize these layers and to align and to create your line of flow through the nano layers. Okay, because as we explained in the last time, by aligning or using your electrodes, you're aligning those layers in a certain direction, and becomes quite important when you're looking at coils to create those layers in that certain direction that you're wanting, and then for your plates as well. So it's the same understanding and method as the previous one that we have to bring through all the time. And once you've completed the draining, always put the lid back on. So we essentially are draining the voltage to polarize the surface and dictate the direction of the formation of the nanostructures, and whether it's in the coils or your plates. So we're dictating which direction that we're wanting that flow to happen. And then keep the lid closed for a minimum of 2 weeks again. And if you remember the little video on the nano laying process there, is during this drying or conditioning period where your nanoparticles will be finding their position in respect to each other. And so it becomes very important as to why we need to dictate that direction so that they can then find their positioning. So if you're going to leave it for 2 weeks, then you can just open the container, again leaving a small opening, because we want to change from that caustic environment to the air environment gradually. So when you know you're wanting to end this process, then 2 or 3 days beforehand, one just creates a little opening in your box to allow for this change in condition. And when you take your plates out, then we all have to do the very important to handle delicately. If you can, just hold at the corners, and then we need to rinse the caustic off the plates. Please remember, this is a very important stage because we do not want to take any of that caustic into the production of our ganses at a later stage. So we need to wash this caustic off with distilled water at least 5 times before we use them in any application. And it's important not to damage the nano layers you have built. It can take you 2 weeks to 2 months to build these layers, so you don't want to go in there and just grab all your components, because you've essentially then undone 2 months of work. So please handle very carefully and place in a storage container until you need it. Store your plates upright and always hang your coils. And I think I remember, Sandor, you said that you always want to have a little bit of moisture in your container when you're storing these plates.
Yes, certainly. One of the ways is just to wet a little bit of tissue and to place it into your storage box.
Great. So essentially, this method is used to primarily re-nanocoat your copper plates after using them in your GaNs production. This method can also be used as an option to add additional layers to your plates after the hot caustic method and its long drying period of up to 2 months. And then this method is also used to nanolayer your zinc plates for your zinc oxide GaNs production. Because I think many of us has found out that if we try and nanocoat our zinc plate by immersing them in the hot caustic, by the following morning when we come back, we don't have any zinc plate left, because the environment is just too strong for the zinc. So it's best to use the steam coating for any nanolayering of your zinc plates.
I had good results with such a 0.5 or 0.7 millimeter zinc plates in hot caustic immersion process, even for 24 or 48 hours, if the concentration of the caustic was below 5%.
Okay.
So probably even less, such a 2% of caustic relative to the weight of the water would be suitable for zinc. Aluminium is quite different. If you need to nanocoat aluminum for whatever purpose, you have to experiment to find the minimum concentration which creates the changes into the upper layers, but it will not penetrate too deep to destroy your metal foil or plate or whatever you want to nanocoat from such sensitive metals. So care when you use aluminum, magnesium, zinc, which are said to be incompatible with caustic soda. So have to find lower temperatures or lower concentrations, which still can work.
Thanks, Sandor. All right. So any questions on that one?
Yes, Jimmy, I have a question for you or two. First, when you use the multimeter, I have noticed that at some point it doesn't move, it stops moving. So what does that mean? And I have also seen that instead of touching both ends of the particular metal that you are measuring or that you are nano-layering, say copper coil, as one of the probes of the multimeter goes to the mesh wire below. I've seen that demonstrated, but what you showed is the same piece of metal with both probes on either side, one probe on either side of the metal. So is there a difference between doing that and actually using the mesh wire in the box with one of the probes and the other on one on the piece of metal?
If I may answer to this.
Thank you. I would like to know the difference and why it stops and what that means. Thank you very much.
So let's say you have a mesh here under. And you have your copper pot, let's say a piece of copper plate. So now what makes any difference? So you can use your probes to touch in two corners or whatever, or if you connect one of the probes here to the mesh, here is your whatever instrument, millivolt meter or whatever, you can touch somewhere here or wherever you want on this area. So what happens? So this mesh will extend the connection. So it's like the end of your probe. It's just like an extension. So in that case, you will have some currents distributed to the from the point of contact with one probe to the points of contact with the mesh. In case if you have a plate which is hanging and it doesn't touch any mesh, maybe even no need for mesh if you hang properly the plates. It's important to keep a distance from your caustic and your plate and the solid caustic. So here you apply the probes here and here for the best results. Of course, you can touch it to any point, but you have to know that some voltage appears on the wet nano-coated layer, and when you attach your voltmeter with the probes, that will close the circuit. This will be in the shortest way, but also there will be some very little currents, the order of some nanoamperes, here too. So if you use a contact by the diagonally opposed corners, it means you will have the longest straight track covered by these little currents. if you touch, for instance, the probes, one here and the other here, in that case, obviously you will have the current, straightest current here and some currents here around, and some portions will not be affected by that current. There was a Chinese team or a Chinese experimenter who made such tests by checking with scanning electron microscope the quality of the layers in different conditions. So they used touching the probes during this polarizing or polarization process here on these 2 points. Let's say this is case A, this was case B, and this was case C. Once they put the probes longitudinally, once transversally, and one diagonally, and they observed that they had the most uniform nano layers in case of version C. So you have to understand that you create some currents there, and the currents go through the easiest way. So if you have a mesh, you will have currents some in this way, like it's drawn here. Let's say this is D. That's the only difference. It affects the uniformity of the structures, the crystalline, microcrystalline or nanocrystalline structure of the layers which you produce. You are
so what happens when it stops moving the multimeter?
No, you don't deplete, you don't keep the voltmeter until the discharge is completely. That's a misunderstanding due to the word discharge has several meanings. It's not a discharge completely by the complete depletion, but it's a process of alignment through these electric fields and such a small electric currents for a period of 5 to 10 seconds. So you don't keep for hours the ends of the probes until you have no reading. It's no need for that. You just apply the probes of your millivoltmeter for about 5 to 10 seconds.
That's not what I mean, Sander. I have actually done what you're saying, and sometimes when I cover that and come back hours later and I touch both ends, I don't see any reading. That's the question. What stops the movement of the
So it depends on the plasmatic conditions you have into your box. You have here, let's say, a box, and here you have several plates. And you have here different plasma processes. Remember what Mr. Kish has shown us years ago? That was the Coke bottle reactor experiment, when in a plastic bottle, he inserted and then glued hermetically such copper nails, you know, those roofing nails, which are made of copper, like a parachute or like an umbrella. And then he put that mysterious KT liquid here. And then he measured here between different positions. Sorry, I have to move this to be able to extend drawing. So he measured here different voltages. Maybe better I draw it here. So here was the bottle. Here were the copper bits with a little liquid. And he put the voltmeter on different points. And he measured here, he measured here, in all combinations. And maybe some of you have repeated that experiment and you have observed that some voltages appear, let's say between A and B. Another voltage appears between A and D, between C and D, between B and C, and so on. And those voltages are always changing. Sometimes they go up, sometimes they go down, sometimes they reverse their direction accordingly to the plasmatic processes which take part here, which occur here inside the environment of the bottle. So when you have such a plastic box in which you make your nano-coating process, so here also you create a plasmatic environment, and there are fluctuations, and what you measure, it indicates the condition which is for a given moment in given place. So sometimes you measure 5 millivolts, sometimes minus 70, sometimes plus 350, sometimes 0. And if you measure 0, it doesn't mean it's 0, it's just something below the sensitivity of your millivolt meter. Maybe your instrument shows only 0.01 millivolts and you have less there. So you have, let's say, 1 microvolt there, or some nanovolts, so still you have something there.
And now the question is, when you have 0 point, the lower end that your multimeter does not read, is that better nano-coated layering? Or?
No, it doesn't say anything about better or worse. You can try to measure, if you measure between these 2 points, for instance 0, you can try to measure between this point, and you will see eventually a difference.
Okay, thank you very much, Sander.
You're welcome.
Sandor, I have a question for you, if that's okay. This is Dimitri. If I have had some zinc plates that I put into storage, they were just hanging in distilled water, and after some months they started to produce GANs. I am uncertain how clean the plates are, how whether I washed them or not. It was many months ago they were put in there. If they were not washed thoroughly and there was caustic in there and the GANs was produced, can those plates be used again, or do they carry the fields of the caustic?
They carry the fields, so you can eventually, if the plates have enough thickness, you can scrub them, you can scrape them, and you can make a coating newly, or to use them as bare plates. There are different methods how you can clean the surface of a used metal, or an oxidized metal, or a coated metal. So I tried several things. There are chemical methods, there are electric methods by currents, like in galvanoplasty, and I found there are mechanical methods like scrubbing, scratching, and I found that method which is used on the ocean vessels for removing the rust from the surface, or is used by engineers to flatten the surface. It's a scraping. So you need a scraping tool. It looks like a chisel, but the end, it's not so sharp. So the end is sharpened at a different angle. I don't know if you have seen such kind of scraper. Again, I have to share my screen. Sorry for that, Jim. So, you know, oh, sorry. This would be the angle of a chisel, or this is the angle of a chisel, which you can use to cut wood, metal, or whatever. So now a scraper is different. A scraper is just like a chisel, but it's sharpened at a different angle. So this angle here, it's different. And sorry, by holding such a tool in an angle, in a certain angle, and applying certain pressure here and here, then you can just shave little filings of the metal, and you can make it perfectly clean. It's a scraping by a tool, a blade. So the tool looks like a big file or like a big chisel. It's a long piece of metal. It has a handle to hold it, and you use this end, which is sharpened in this way, in order to remove the upper layers. So this is the fastest method. By such abrasive material, it's not so good. It makes a lot of dust and it doesn't make the surface uniform. Such a scraping, it's the best method to clean the surface of such a oxidized or spotty metal sheet, be it copper or zinc. Of course, you have to decide. Is it worth to clean an old used piece of metal? Is it worth for the invested effort and costs, or it is easier for you to get a new clean plate? It's always your decision.
Thank you very much, Sandor.
You're welcome.
I have a question. It's Nicholas.
Hello, Nicholas.
So in the steam process, then we steam, we leave it closed for 24 hours, and then we discharge the plates every 6 hours.
Yes.
For 2 weeks. Every day for 2 weeks?
It depends of your purpose. So you see, when you discharge, you align the layers. It's a process for giving a polarization. You apply an electric force in order to facilitate a certain direction of how the nanocopper parts will align. They probably will be combined with the oxygen from the air. They form some structures of copper oxide or whatever.
If I might interrupt just briefly, there's some other aspect about that I haven't heard mentioned yet, that Mr. Kish has mentioned, which is when the probes are put on the plates, then it's a draining process, which has been talked about, but also the the layers get compressed by that draining process, as opposed to like some people are talking about putting energy into it, and like actually adding power to it, and that would fluff up the layers and make them too fluffy. So the idea is to make the layers nice and tight, so there's no gaps, no excessive gaps in between. And that's what happens when the energy is drained off, like we were discussing. So it might be useful in certain circumstances to make sure you have everything aligned properly, especially with the some of the power applications. But in other applications, you might want to have just a broad range, broad spectrum of absorbability and plasma response in the plate, in which case just making the layers tight is the main idea. So you might want to dab with the probe over the whole surface of the plate in multiple places to sort of gently allow the layers to align by compressing themselves tightly.
So when you do this alignment by voltmeter or discharge or polarization by voltmeter, and I repeat, not by ohmmeter, so we don't inject extra energy. We just use the voltage which appears instantly on the wet surface. So here, if you want to make a nano coating which is very uniform, in that case you use the same direction for polarizing. But in some cases, you want to get you want to get such a nano layers which have a wider spectrum of fields. And for instance, for creating a wider spectrum of GaNs materials, the same. In that case, you can use the polarization in different places. So once you put the probes here, once you put the probes here, other time you put here and here at random. And in that case, what happens, every time, at every certain number of hours, you give to the new layers a different direction. So in that case, you will have a more random structure. Sometimes you follow to have a very uniform structure, like for energy applications, or for shielding application, for holding the fields inside. In that case, you apply in one direction once, and if you want to make a wider spectrum of arrangement of layers, in that case, you can change several times. So this applies also to how many times you do this alignment or polarization process. So you got the tools, you got the principles, and now you have to judge about how to use it. So for instance, you get a carrot, you get a knife, a chopping board, and you decide whether you want to cut it in round slices, you want to make longer bits of carrot, or whether you want to chop into small bits for a saute or for whatever purpose. You have the tools, you have to think about what you do with your tools, with your method, and choose the purpose, and choose according to the purpose the way how you apply it.
How about making the GaNs for medical purposes?
Yeah, there also it depends. You want to tune it for one kind of field strength of, let's say, CO2 GaNs, or you want to have a broader spectrum. Once Mr. Kish described for such special medical application, used a way to do nano coating by masking certain regions on a plate before the nano coating, and then to apply a second coating with masking taken off, or used to pour caustic in drops in certain streams. And then when you got the final nano coating, you got something like this. So thicker and thinner coatings on different places. And that was the purpose, to create a broad spectrum of fields. But these lectures of Monday are usually about the basic understandings, and we don't want to go too deeply into the many variations and the many kind of applications which you can develop it for years.
Thanks, Sandor, but it is good to give us that perspective that a lot of us in the beginning thought, well, it was just a simple process of nano coating and that was it. Now we begin to understand there's so many different nuances about it, and it's how we use it and what we use it for that makes a difference. So it's very...
So basically, as I said, Mr. Kish gave us the tools, the methods, and what you create with those tools, it's up to your wish and your imagination. You see, from the same carrot, one can cut long strips somebody with the same knife or can cut round shapes or cubes or whatever shapes, or you see the Chinese cook, the Chinese chef, that he chops such a beautiful flowers from the same carrot to put it as a decoration on the top of the dish. It's the same carrot, it's the same knife, just it's a different way how you apply according to the purpose.
If you have potassium hydroxide in your mix, would that first of all, would that have to be put in the steam method, or can you just use the plain sodium hydroxide?
Yes, you put always, you use potassium. A little potassium in the caustic makes a huge difference.
And how much is a little, Shandor? Somebody's asking how much do you add normally in the nano coating box? You mentioned that in an earlier teaching of these, part 3 or 4, I think it was. But you have a standard mix that you recommend, correct?
Yeah, it's not standard. It's something which has been proven that it gives constantly good results. It doesn't mean it has to be a standard. But if you do it in that way, you shall have no failure. So you can use more or less caustic, you will get different results. Also changing the ratio of potassium and sodium also makes a difference. So I used to use about 1:3, 1:4 ratio of potassium to sodium. But sometimes you can use only just potassium, and you get a different energy from that than from the sodium. So in consequence, the particles in the nano layers will be spaced differently because they get different energy from just the potassium.
So generally for
plastics like strontium hydroxide or whatever.
Yeah, let's not get into all those details. I was just trying to find out how much, like for example, in a liter of water, how much would you put in for the immersion technique in sodium hydroxide and potassium hydroxide? I think you mentioned. If you could do it on the screen share, that'd be great. Thank you.
Yeah, so let's make it visual. So basically I used for 1 liter, for each liter, so let's say 100 grams of water. Usually I use about 40 grams of sodium hydroxide, let's say 10 grams, but sometimes up to 15 of potassium hydroxide. So this usually gives a good results. And you see these are total 50 grams, and 50 to 1000, it's about 5% and not more. So no need always for too strong one. I saw people that put 10 times more. So they had half by weight, half caustic and half water. It's no need to waste so much caustic. You can go for 20 grams of sodium hydroxide and for just 5 grams of potassium hydroxide. Or you can use just a 10%, 1/10 of potassium there. So you can use, for instance, 40 grams of sodium hydroxide and let's say 4 grams of potassium hydroxide. You can experiment whatever. Just this is the ratio which I found bringing constantly proper results. At the beginning, I did nano coating with much less. I didn't use the 40 grams of caustic per liter of water, but I used only 20 grams, and still it made a beautiful coating. This is just not a standard, it's a guidance for a starting point. And from here you can start to experiment what happens if you put more, or you put less, or if you change the proportions.
Yeah, that's a great general guide, I think, that will help many people. Got a quick question on the live stream here from the same person, Philippe. Can I put copper and zinc together in the box to nano coat?
You can, but we don't recommend, because you will get quite different results. So whatever you put into your nano coating box, it will leave some tracks. It will have an effect upon the nano coated layer. So you get a mixture of something. So even that chicken mesh, which we used to put as a spacer at the bottom of the box, it's not a must to use a chicken mesh. All the purpose is to keep a distance between the solid dry caustic before you add the water and the plates. So you can use such a copper mesh or copper wires just to hang them, and you don't need that other material there. Or some people just use such a plastic mesh. If you want to have something pure, you don't add too many other things inside.
When storing the plates, you were storing them hanging, and you spoke of that it needed to have a moist environment. Is that environment created with water?
Yes. Yes.
No?
Moisture means basically water here, not alcohol. You can create the moisture by alcohol also, but you can add some whiskey, but it's better to add just some water.
No, I wasn't speaking of that. So we've already washed the plates, they're ready to go, and we're storing them by hanging them in a closed container with a little bit of moisture, like a damp cloth.
Yeah, so you can hang them, or you can use any other way. For instance, if you have a plate which has a bent corner here, when you put it with the bent corner, you don't need to hang it because the nano-coated surface will not touch the bottom. So this is another way. Or alternatively, you can just keep it hung. You can hang it too. And you can add a little piece of cotton or a piece of paper tissue with 1-2 grams of water, and then the air which is inside will have certain moisture. You see how rich men who are smoking cigars take care. The hand-rolled expensive cigars, they have such a box which is called a humidor. A box with a constant, I don't know how much, 40% relative humidity with a hygrometer. Or if you go to a museum and you see pictures or all the wooden parts of furniture, in some corners of the rooms of the museum, you see such hygrometers, and always they take care to maintain a constant humidity to preserve a certain condition. So same, the nano-coated layers preserved well if you don't keep them into extreme dry air, but you keep some relative moisture there. And of course, you keep them into closed container before to use it.
Thanks very much, Sandor.
You're welcome.
We just look at the time. We need to move on to the next section.
Yes, let's go on our project. Otherwise, we could hold a 1-2 week seminar just about various methods of nano-coating.
Yeah.
But there was a question in YouTube. What is the purpose of the wire mesh and steam coating?
Keeping a distance between the copper parts and the caustic.
Yeah, I just use it because then I know how much to fill my container with the water so that I don't fill too much that my plates are going to be immersed in the water. So I use it as a bit of a measuring method.
And secondly, there is again, I have to draw. There is another purpose. Maybe another purpose, depends of your style of working. If you have many bits, many parts, let's say you have many parts here, let's say leaned against the back wall. In that case, it may be difficult to enter with your voltmeter probes at both ends of it, and it's easier if you connect one of the probes to the mesh, and you just walk around with the second probe from one piece to the other. It gives a convenience when you do this discharging or polarization. It can give you a convenience for having an easier contact while you have here the liquid below. These are obvious things, but no problem, you can ask and we will clarify.
Is this in the drawing process?
Can we move on? And no more questions, thank you. Otherwise,
Thank you.
we will not go home today.
We have to fit in a time frame.
Yeah.
And there is much more to see.
It just shows that there is such a demand for the knowledge on the nano and the GaN. So we'll have to work on something for next year, Sandor.
Yeah, sure. And all the questions are very useful. We see how people understood what they are not clear about, and we may always improve the way how to give the knowledge gradiently to not miss any important detail.
Yeah, absolutely. All right, so on the final section there, we're going to look at the on the GaNs, and I'm going to be looking at what we call sort of the liquid plasma and the zinc GaNs. So the liquid plasma water, this is what we call when we've made our GaNs, and so far we've explained how to make your CO2 GaNs, and you've washed and now you're storing your GaNs in a glass jar, and you filled it with distilled water. So as you can see in the picture, your GaNs has settled down to the bottom, and you've got all this water which is sitting above your GaNs. So what we do is we only use the water which is above the GaNs. We do not use the GaNs itself. We do not ingest the GaNs in any way. So we are only using the water. In this other picture there, I've just illustrated with the arrows that you've got your GaNs and the distilled water sitting above your GaN. So this is the water that we use only. And so we'll take that water out, use it for different applications. We'll show you in the next workshops how we use it in agriculture, how you start using it in the health. But it's just the water that one is using. The simple method is just to take the water out with a syringe, take what you need, and then you just you fill your container back up with distilled water again. But just please bear in mind that when you refill water in your container, you're going to sort of fluff up all your GaNs materials are going to start floating around. So please allow at least 24 hours for all this GaNs to settle back down to the bottom before you use that water again. You don't want to take in any of the GaNs in your water. So let's take what you need, fill back up, and then allow to settle before one uses it again. So this is what we we'll term as the liquid plasma water, and so it be used in many, many applications.
Jim,
Please.
can I suggest something?
Yes.
I have a big tank, a 100-liter tank, and I keep the GANs in small, well, not small, if not jam jars down below, not on the bottom of the tank. So I don't disperse all the GANs, and I find the interaction between the different pots of jam with the GANs in it gives it another field in between the bottles. So it also helps to produce this GANS water. And we don't have the problem of mixing the GANs with the water when you refill the tank.
That's an interesting idea. If you have the GANs closed into a separate container, some fields of the GANs will influence the water, but it's quite different compared to when you shake the GANs within the water thoroughly, so you oblige the water to go through the two adjacent particles of GANs, which gives more energy to it. So the results are quite different.
Yeah, this is the teaching of Mr. Kish, John. So this is what we're going with for now.
Fine, yeah, but I don't close the jam jars. I leave them open. I leave them open. The contact between the water up top and the water in the jam jars is continually recirculating, but it doesn't arouse the GANs down at the bottom as much.
Well, yes, did you hear what Shandor just said? Yes, reinforce what you just said, Shandor, about the mixing of the GANs in the water, how it filters through.
Now let me show my video. If the host would allow me to share my video, I could do something.
Yeah, go ahead.
Oh, sorry, I have to set the, just give me a second. So I have to change the settings from day to night. I do an address here. And now this is complicated. I have to open the Skype program to adjust it. So maybe this -8 is fine. Maybe the white balance shall be adjusted to today's daylight. And I have to remove the virtual background. Oh, just 2 more clicks. Okay, so no more virtual background, so it's fine. So you see, here is the GANs, here is the water, and it's a different thing if you have some water which is changing here, and it's different if you shake it thoroughly together for a minute or two. So you have a much better interaction in between. You see, the difference is like if you make a cocktail, you can pour together the components and to add that fruit juice which you want, and it makes a difference if you shake them together, so you get that flavor all around. So here also you get a different energy into the water, and then you let it to settle down thoroughly for about 24 hours, and then you have something different here than if you just would had some jar with closed or even open GANs within. By the way, this is CH3 into the water. It has been shaken thoroughly, and it's now after 2 days, it settled well. So CH3 doesn't settle so fast. So I had to leave more. CO2 settles in half an hour. For CH3, it was needed for more. So now I can carefully take the water from the upper part, probably by siphoning, pulling out through a tube, to not disturb what is here below. That's a difference when having such a jar with some GANs in the bottom. So remember that shaking. And what Mr. Kish explained, when you do that thing, think about when you have a water filter jar. You know, these water filter jugs, not jar, sorry, the jug, which has here a special filter with different layers of fine sand or microfilters and carbon or whatever, and you put water here. When the water pours through all these things, you get a purified water. So now, similarly, when you create a plasma water, you have a jar or you have a bottle, you put GANs inside and you put the water and you shake it thoroughly. So what happens? You force the water molecules to go between the GANs particles. So you force this to go through. And an interesting thing happens, just let me change the color. If you have original water, you have water molecules which are at different energy levels. So a bigger spot or a smaller spot means a different energy level. So how this happens in reality, you have an oxygen connected with two hydrogens. And this is one state of your water molecule. But the distance between the hydrogen and oxygen can change. So it's a different energy level when the oxygen and hydrogen are close, or when you have it at a different energy level. You have the same angle, the same molecular structure, but you have a different distance here, different spacing. More energy is embedded into your water, so you have a more distance between the hydrogen and the oxygen. So now when you have the GANs particles, which act like a filter in case you shake it together with the water, then you force these water molecules to go through. And what happens if you have something with a lot of energy, that when it will go through, it will get a certain level of energy. And when you get something with excess, that will give some energy to the GANs. And when it goes through water molecule with less energy, then it will get extra energy. So here is when it goes inside, and when it goes outside, it will be uniform. So the result will be that you will have the water molecules all at a certain energy level, which is determined by the energy level of the GANs which you used. So that's why that water does its magic, because you fine-tune that water's energy level. It's a difference if you don't shake it, but you just put here a container with GANs. It doesn't stir up, but the water doesn't go through the GANs. So please understand that, John.
Yes, I understand that perfectly well. I've got another thing that helps that way. I've got a container which I've got over half of it filled with GANs, and I pour the water up top, and I've got a small seepage which down below, and it drips into bottles, and this is just water that drips down below and no GANs. And then afterwards I mix all those waters together, so I've got different GANs waters all mixed up. And those jars, I've got about a dozen jars down below with different concentrations of GANs, and every time I stir it with a long stick, I stir the GANs inside each jar to produce that movement.
Okay, I understand. So you are experimenting your own developments, which is fine. So don't forget this basic understanding lectures also for those who are absolutely new in this field and you are more advanced than others. So let's don't confuse them with this, the others with too much information at once. Let's stay at the basics. And if there is not understanding about the basics, all the questions are welcome.
All right. So as Sandor explained very nicely there with the water, by just taking the water off the top, that water contains the magnetical gravitational fields of that GANS in the container. So if you have CO2 in there, then the water you're taking off will contain the fields of that CO2. If you've got zinc in your container, then the water will contain the fields of the zinc. So this is how we can use the water without actually using the GANS itself. And then it can be used in different applications.
So I have a question. It's Nicholas.
And let me finish, and then we can go to questions, please.
Oh, very good.
Thanks. Okay, so that was liquid plasma water. So it's very important to understand, as I said, because when we start looking at how we're using these in agriculture and particularly for health, it's very important to understand what you are using and what you've created. Okay, so the next part, the last part, was the creation of the zinc oxide. And this is just also another method, because we introduced last week one method of making the zinc oxide GANS. So this is another way of doing it. So just as a review to remind everybody from the last time, when we showed you when you're making your CO2 GANS, and if you're making your CO2 GANS with your zinc plate and your nanocopper plate, if you don't put an LED or load on that, you just connect the two wires, you are essentially only producing 90-95% zinc and only your small 5 to 10% of CO2. So that's if you have your CO2 set up but with no LED or load, then we are producing a mixture of mainly zinc with a very small amount of CO2 gas. And there's just a reminder of the pictures to actually see the difference between the CO2 GANS and your zinc oxide GANS. The zinc oxide GANS is very white, and your CO2 has that slight creamy color. So you are able to tell the difference. So when we're looking at the second method of creating the zinc oxide GANS, we use the same setup that we have put together for our CO2. However, instead of using the nano-coated copper plate, we're using a zinc plate. And it's the same setup. We have the same distilled water with the 3 to 4% salt solution. So it's exactly the same setup, but we just have two zinc plates, one plain zinc and one nano-coated zinc. And when you connect these two plates up, there's no LED, so you can just connect them up together. And then through this environment, we are then going to be creating 100% of our zinc oxide GANS without any CO2 GANS in there. So it becomes very important when we're looking at when we're dealing with certain health applications, it's what GANS we've created so that we can use it for specific applications. And there's nothing wrong with the other method, it's just using it for what we want to use it for. So because zinc we use a lot on the emotion side, so when we create it, we want to know that we have created 100% of the zinc. The other method, we know we've got mainly zinc and some CO2. So there's nothing wrong with either method, it's just knowing what to use and for what application. And from that CO2, it's the same. We take out the zinc oxide GANS from the bottom. of your container, as we explained with the CO2, and then you start washing, because this collected GANS will have a high concentration of salt. So we just add distilled water to the GANS you've collected and allow this to settle back down to the bottom, and as pour off your water and refill with the distilled water. Now you can repeat this 6 to 8 times to ensure that the salt is all washed out. And you know, a lot of us can just use the sort of a simple taste test method to make sure that we have all the salt that is out of the water. And I think, Sandor, you have a more sort of scientific explanation that you'd like to bring in on how we can know with it we've washed all the salt out of our water.
Yeah, so tasting, it's limited, it has a limited sensitivity. Think about if you take distilled water in your mouth, you rinse your mouth, you spit it out, and you measure with a TDS meter, you will find such a 200, 300 ppm concentration of salts. So you already have salts in your mouth, so you cannot sense the lack of salts below that level into the water. So what I used, I say 6-8 times may be valid in case if you wash, you rinse the GANS with 4-5 times more water than the water of the GANS. Let me start my video for a second. If you could stop that sharing to let be seeing this.
Yeah, I have to stop sharing there, Jim. There we go.
Okay. So here it is. I had originally this amount of GANS with water. About I use let's say 75-80% of the bottle. I need some free space for shaking it. So this is the total amount from here to here, which I use the total volume of the glass which I use for mixing the GANS with clean water, with distilled water. So originally I had this level, and I added this level of extra clean water. So this means that I doubled the quantity of the water for the same amount of salt which was here originally. Originally here, I had 3.5% salt solution. Now I am not considering the volume occupied by the GANS for simplicity. So we work with extra safety in our calculation. And for every time when I add a double quantity of water, I shake it together, and then I remove the water from the top of the extra volume which I added. I am reducing to half the salinity by dilution. So if I had originally 3.5% salt here, after the first dilution I have 1.75% of salt. At the next step, when I dilute it again, I get half of that, such as 0.8%. And here I wrote on this side in ppm, in parts per million, the quantity of the salt in the water after each dilution. And the number of washings of dilutions I marked after each with a strike. So I know when I have 15 strike, I have the 15 times diluted. So here from 3.5% salt, which is 35,000 parts per million, I went down by first washing, second, third. By the 15th, I reached something of around 1 part per million, which is the quality of distilled water. So let me explain that in another way. I share my screen with a calculator. So you use a simple calculator, and you put the salinity of the original GANS water. If you use the 5% salt, then in parts per million, it will be 50,000. You know, percentage, it's part per 100, and part per million, it's a little more zeros at the end. So now, if I double the quantity of water with each washing, in that case, I divide by 2. First wash, we reduce the salinity to 25,000 ppm, and the purpose, the target is to bring it to 1 or below 1. So let's see, this happens after first washing, second, third, fourth, fifth, sixth, seventh. After 7 washes, we are still at 390 ppm, which is the salinity of tap water. So it's far from having the salts removed. So 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. Only after 16 dilutions by 2 with distilled water, we reach to so-called no salt condition. So we have salt only in traces. If you have, for instance, 10% salt, sorry, let me clear this. So it's 100,000 ppm. In that case, if you dilute by 2, you need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 washes. Another case, let's say you use 5% salt and you dilute it, let's say 4 times, so you add 3 times more water than the quantity of the GANS water which you had with salt. In that case, we divide by 4. So you need how many washes? 1, 2, 3, 4, 5, 6, 7, 8. So after 8 washes, with dividing the salinity, diluting 4 times, you can reach to this no salt condition. So always how many times you wash it, it depends of how much salt you have from the beginning and how many times you dilute it. Now a point to remember, if you dilute by adding the same quantity of water, which was originally with salt water, in that case, you use, in case of 5% salinity, you use, let's say, 16 times more water than the original quantity of salt water. But if you wash it with 4 times more, in that case, you will need 32 times more. So if you want to wash it fast, you dilute it with a lot of water and you waste a lot of water. But if you dilute it in small steps, only diluting always to half, in that case, the process takes longer. So you need 16 times the washings. But you use the less quantity of distilled water. And another point, you don't throw out the salt water which you used for washing. You put it into a bottle where you put a mark, so what did it contain? So what does it contain? So this is CO2 GANS washing water, starting with 0.35 salinity. And then you have a distilled water, which contains some salt. It contains also some energy of the GANS. So this you can use it to refill your CO2 GANS kit when the water evaporates. Or you can use it for your new CO2 kit instead of distilled water. And you know this contains a little salt, you add a little more salt, you can calculate that exactly. And you don't waste this washing water, you reuse it.
So,
About how many times you need to wash it to really remove the salt. And another point, you can reduce the salt content only to the salt content of your washing water. So if
well, that's right. So what ends up being practical, Chandra? I think most people I know do not wash the GANS 16 to 32 times. That doesn't seem very practical somehow.
32 is not needed.
We used to say, I think people used to say like 4 or 5 times, something like that.
It's a very salty water at the end. It's a high ppm, high concentration, like you have the tap water or a fountain water. I just showed you with my
You
calculator.
can always taste the water.
Taste will show only to a certain limit because you have salts in your mouth. How
Well,
you
what is the limit for taste? What is normally taste? Like 300 parts per million or something like that, perhaps?
Approximately, yes. So you have 1%
Okay.
salt in your blood.
What's
So that's your limit. So it's to 10,000 ppm, and below you just feel it's a sweet water, but you can't really find the difference.
and the idea to get it as pure as possible or as close to non-salty is not to just remove the salt for taste or for sanitary reasons, but to allow the GANs to fully
To expand its fields.
Right. Okay. Thank you.
And when you have the GANs and you have the salt together, there is a field interaction in between. So part of the fields of the GANs will be locked to the salt, which is dissolved. If you remove the salt, you free up the fields of the GANs. So you see, when you wash it, you do it so many times. Whenever you hold it in your hand, you feel stronger and stronger fields. So this is, if I approach the hand to it after it's thoroughly washed, it's like approaching to a piece of ice. If I hold it in my hand, just my hand gets numb. Now I feel numb until here because I had it here in my hand. You feel the difference. And the easy method, as I've shown you, everybody has a calculator, a basic calculator. You input how much salt you put it, you use 7% salt. No problem, it's 70,000 ppm. Dilute it by half. Number of dilution needed to reach to 1 ppm, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you are there, or 16 eventually. It's easy. Just you have to understand what happens. You have one quantity of salt, and you always take half with the rinsing water. It gets smaller, smaller, and smaller. If you understand that, it's very easy to calculate.
Also bear in mind, when one starts using that GANS and you're using and refilling with water all the time, every time you are diluting it again and again.
Yeah, please let me remove this from my desktop because I really feel my hands really icy.
Thank you, Sandor.
It's a huge quantity. The strong feels. So if I would had any pain in my hand, for sure it had to be gone by this moment. It's like when you get it purified, pure CO2 GANs, and you touch just the bottle with its plasma water, you just feel like you took a lidocaine injection in your hand. Actually, you feel the fields different from different gases. CO2 gives you a cold sensation. Chilly.
Okay, so that was very valuable information there in terms of the washing as to why it's important to wash as often and to get it down to very small salt concentrations.
So you see the standards for what is called the pure water, purified water, what is called the distilled water, and such a 1-2 ppm is fine for the salt content for distilled water. But we go over to the best as much as possible.
Right, so when you're making your zinc GANs as well, you're also going to be producing the amino acids. So that's that, after a week or two, that'll be that shiny layer that forms on the surface of your water. And this is the amino acid with the zinc oxide connection. And so you want to collect this as well. So you also just take your spoon and scoop this off and place it in a separate jar. You don't wash this, but just label it as to what it is, because it comes into play when we start using the different GANSs, particularly on the health applications. So we need to know what we've collected. So one needs to understand what conditions you're creating in your box. So if we have the zinc plate with a nanocopper plate and no load, no LED, then we're going to be producing about 90% zinc and 10% CO2. If we take a zinc plate with a nano-coated zinc plate and no load, we will then be producing around 100% zinc oxide GANs. So it's just being aware of what conditions we are creating in our box all the time. And to say each one that we produce is just going to have different applications in health or agriculture. So one has to be very aware of how you set your boxes up, what you're doing, and what you're wanting to create at the end of the day. Okay, any questions?
I know Klaus Dieterbauer had his hand up there. Do you have a question, Klaus?
I have a question. It's Nicholas.
Yeah, hi, Nicholas.
So I have my jar now with GANs in it. Say it's a quart jar, and with distilled water. And we leave it for 24 hours. We shake it up, leave it for 24 hours to potentize the water. What percentage or how much GANs per water is necessary? If you have less GANs, do you need more time to potentize? What is recommended in terms of how much GANs per water that you might have?
Let me answer there. First, when you do the washing, to avoid misunderstanding, usually you don't wait 24 hours between two dilutions, just you watch until the GANs is settled well. Sometimes it's 30 minutes, sometimes 2 hours. And when you make the plasma water, if you have, let's say, 1 liter of GANs, that's enough to make about 10,000 liters of plasma water. Of course, you don't do it at once. So you put, let's say, 1/10 of your bottle has GANs, only 1/10, and you add, so let's say you have 100 grams of GANs into a 2 liters bottle, you add 1 liter of water, you shake it well, you let it to settle down 24 hours, then you take the water from the top. Just a rule of thumb, 1/10 ratio, it's fine. You can go even for less, or 1/20, such a 5%, but 10% will give you guaranteed good results. Just let me show again. So here I have even less, so it's maybe 5% of GANs compared to the volume of the bottle. This is a 5 liters bottle. This is a CH3 GANs. So I add as much water to let here little space to shake it. And you see how much is it. It's about 1 finger height. It's not too much. Here maybe there are 50 milliliters of GANs in this bottle. Shake it, you let it to go down to settle very well, and for safety, to don't take GANs particles which are not settled, you just take from this top. So you put a tube inside and you pull by tube. Otherwise, if you bend it, it will stir up. I have another idea which is not tested yet. It's experimental. Just I had the idea that I had these empty bottles. So I cut the bottle in half and I turn back. So I cut it in half. I turn back this part here. And I'm thinking to easier separate the GANs, to not stir it up when I take it out, to pour here, which I have water with some GANs, and probably this funnel will help for what settles down to get into this compartment, so it will be easier to take out from here water without stirring up all the GANs. But this is just an experimental idea. Just as an answer to your question, it's just 10% of GANs to the added water will make a fine plasma water, or even 5%.
Very good. Another question would be, when harvesting the water, the GANs plasma water, if you pour it off and you watch very closely, and as the GANs approaches the lip, then you stop pouring it off. So you're getting a visual there, and you're being very careful that no GANs passes over. Is that process also valid?
Yes, pouring off the excess has the risk that you will stir up again the GANs. So you can still use that method, but carefully, if you take only the top half of the water. And if you are very careful in your motion, if you have a shaky hand, ask somebody else with a more stable hand to do that. But if you look at the wine makers, or who are making not a wine, but how to say, into a fruit wine, a cider, for instance, always they have a small deposit on the bottom after the first fermentation, and in order to not stir it up, they just put a pipe inside, and they pull the excess through the pipe without stirring up what's on the bottom. So you can use such a pipe eventually with a small pump. You can find it for a couple of dollars from such a supplies shop of supplies for aquarium owners, for fish tank owners, or in different other places. You can use just a simple hand pump to pull it out, or even just a big syringe, such a 100 milliliter syringe, which you extend its end with a piece of flexible pipe. It's just a technical point how you do it, how you separate it without stirring it up.
Well, if you're going to refill and shake it up anyway to repotentize your water, you disturb it some with the pouring.
No, when you refill it, you want to shake it thoroughly. You shake it again thoroughly to make a good interaction between the GANs and water. But when you take out the plasma water to use, you don't want to take any GANs particles, but only the pure water. That makes the difference.
Any other questions?
Yes, I have a question.
Go ahead.
Okay, actually I have two questions. The first one was, is it possible to filter the GANs instead of diluting the water constantly? Could you filter the GANs through a filter and remove a lot more water that way in order.
Yes, it's possible. If you go to laboratory supplies companies, you'll find all kind of filters with all kind of mesh sizes. They are not cheap. They are not cheap, but you can find a mesh size that it filters out even the bacteria. But it costs. If you want to add an extra safety to filter out an eventually floating gas particle from your plasma water, you can try to use such a paper filter, like you have such a conical filters for making coffee. In some parts of the world, they don't use espresso, they use a filter, paper filter, which you put in a funnel. Have you seen those?
Oh, of course. And you feel that's sufficient?
It's not so efficient like a laboratory filter, but it will take out a lot. You see, these filters, you put that into a funnel. If you have no funnel, you just cut a bottle in half and you get an improvised funnel. You put this into a jar and you pour here, and it still filters some bigger particles.
Okay, I was thinking of using it perhaps as a process to wash the GANs and not have to, do it so many times, because you could remove.
For washing is not good because it's hard to recover the GANs which stuck into the paper.
Okay.
It's virtually no way to recover it well.
Yep.
A lot will be stuck there, and it's a big loss.
Yes. My other question.
You see the water filtration systems which some companies are selling for homes. They cost about $200 or something like that. It's a bigger device. It has osmotic filter, carbon filter, sun filter, whatever filter. And those have always some pumps. And while it filters you 10 liters of pure water, it wastes other 50 liters just for cleaning the filter. So because it brings a strong jet, forcing the dirty water through the filter, then it gives a reverse jet, which will be finally wastewater, just to take out again the dirt particles from within the pores of the filter. Otherwise, the filter gets stuck.
Yes, I understand.
You can think about such a devices, but it's not a basic level. If you go to industrial size production, in that case, you will study about water filtration systems and you find the method.
Of course. Okay, can I ask one more question, please?
You already asked. Yes, you can.
This question regards the GANs water losing its energy over time. A man came on some of the workshops and a couple of times and talked to Mr. Kish about the GANs water losing its effectiveness over a period of time. And Mr. Kish never disagreed, but he didn't seem to count it as being very important. And I thought that he made the comment once that if there was even a single particle of GANs left in the water, it would keep the water energized.
We didn't make measurements for one single particle of GANs or 10 million particles of GANs in the water. Of course, if you have a plasma water, which has, let's say, no particles of GANs inside, just the water. Of course, it has an efficiency. Of course, it will decrease its efficiency. Why? Because of interaction with fields of the environment. And nobody can tell you what kind of fields you have in your environment. Eventually, I can feel what conditions I have in my environment. So whatever fields or radio waves or whatever you have, those have an influence over the water, of course. So it's good to make your plasma water, you prepare, you shake your GANs with water in the evening, and in the morning you stream it and you use it in the next day, and then you make again a new one. So that's a method to be sure that you have a good, fresh, very active plasma water.
Okay, I guess some of my questioning revolves around when we take the water off the top, won't it still likely have a very few particles of GANs in it?
It is possible, and if you want to be sure that it has none, then you can again stream it through a paper filter as I shown before.
Okay, I'm not coming from a standpoint of not wanting the particles. I'm coming from a standpoint of actually thinking that maybe a very few particles is desirable.
Not really needed. So a gas particle, it's like a power plant. It's like a little sun in miniature.
Correct.
You don't want to take the whole sun in your home to heat it up, is it so? Or you don't take the power plant, the nuclear power plant in our house just because you need a few kilowatts of power. Same with your body. You don't put the entire powerhouse inside.
Correct. I was thinking of the particle of GANs being so small that it would be like the sun in a universe.
Yeah, it's behavior like of the sun.
Yes. What about when, like, the bottled water that they're making down in Africa?
We don't have description publicly available of the whole technology process of making, so don't ask about that. I cannot answer.
Okay.
It's a certified by the FDA. It has this quality certification, so don't worry about that water.
Okay. So
can we have another question? Sorry to interrupt. Can we have anybody else that wants to have some other questions?
I wanted to ask Sandor, do you measure the pH of the GANS water you produce?
I'd like to, sorry, but I don't have a reliable pH meter. I have some strips for such a test strips, and those are not bad. But I got in my neighborhood only strips for the pool, and this is limited to measure up to 7.8 only. So I'm not lazy. I'm up and working for at least 100 hours a week. So probably I have to order some pH measuring strips by mail order and to get them.
I comment. I bought a pH meter, an electric one.
Yeah, those are not so reliable like the chemical ones because they need calibration. And they need a thorough cleaning because if you have left some small particles on the sensor, it will affect the next measuring. But still, they are still good for some testing, but time to time you have to recalibrate them. You need calibration solution.
Yes. But I've tried different GANSes I've produced, and I've managed the measurements from 7.6 to about 8.5. In different GANSes.
Yes, sure. So probably CH3 containing a lot of hydrogen, it's more acidic than zinc oxide, which is more alkaline. Of course, you will find differences. And the nice point is, if you have a vial filled with a certain mixture of gases, CO2 and zinc oxide gas, for instance, and you put that closed vial into a glass of water and you leave it overnight, next day you measure the pH of the water, how changed, you will find you will get a more alkaline water compared to what you put in. So this is the base of one of the products which you can find on Cash Foundation's web store, which is called the water alkalizer.
One last question.
Yeah, there has been a couple here that were put into Q&A. Can someone spray the liquid plasma water onto a bed sheet for medical reasons, and how is the different handling of GANS affect the person?
I don't think you want to sleep on a wet sheet.
A fine spray would work.
Yeah, and evaporate and dry, yeah. And
we still have the fields of that CO2 there. So even though it would
Please
evaporate,
understand, if you have a plasma water, if it evaporates, it's gone.
It's a different plasma.
Chemically, it's just water. If you look at plasma water, from all chemical analysis, you find it's just pure water, nothing else. And if you evaporate it, it will be gone.
Aren't the fields go
So
somewhere?
if yes,
The
they go with the water.
The fields of the dry GANs are different.
No, yes. So if you want to make a special patch, such a health patch, you can use it. You close it. You put the plasma water on a piece of absorbent material, like a tissue, and you seal it into a Ziploc bag. Then you have its fields there, but that you use on certain parts of the body in a certain way for certain conditions. If you have no headache, don't you take aspirin? Do you take aspirin? Do you? Same with such a plasma water patches. You use them when it's needed and as long as it's needed. You don't use them continuously. You use it for 10 minutes, 30 minutes, depending on the case. You have to know when to start its application, when to stop it. It's not you just sleep on a big plasmatic patch. That would be too much.
all right, we're now going into the applications, which we will be covering in the next series of work.
Okay.
Yeah.
So,
So you make a patch of the size you need, and I don't see the reason why to make an entire batch sheet with a lot of expense.
we'll let Dr. Rodrigo explain to us.
Yeah, more applications of that. Okay. And the last question here is, what is the property of the amino acid? And does it have fields extending like that of the GANs?
Yes, I do. But it has its own fields specific to its structure. And different amino acid created in different conditions has different properties. Look how many kind of amino acids you have in all the living entities on the planet Earth. So all life is based on some forms of amino acid, and some are connected to magnesium, some are connected to copper, some to iron, some to whatever else. And what property does it have? It depends on the amino acid. There are many kinds of amino acids. About the usage of amino acids for health, for instance, you will have to watch Dr. Rodrigo's lectures when he talks about the applications, or whoever does such a health teachings. Now, today's subject is not the health application, but the understanding the basics.
Yeah, we will be going into a lot more of the applications of using the different GANs on different aspects on the body. You know, once we've gone through and all learned how to make all the individual GANs, then we'll show you how to start using them. All right, I think that's it for today.
May I ask a question or two?
Is it relating to the topics? Right.
I think so.
Quickly.
First question. What is the size of a nanoparticle, a GANs nanoparticle, compared to a water molecule?
Very good question. So, can you tell me what's the size of a water molecule?
I think it's possible to surf. I don't have it in my head.
So, okay, I'll take it from your note.
I will question the possibility of filtering out the nanoparticles.
Yes, there is possibility. So,
yeah. Another thing, I will counter the saying of bad thing to spread something on a bed. I have to counter that because it's not a correct information. When you use pure, what we call pure liquid plasma, it will contain particles, but very few if you have made it right. And when you spray a bed, you will have a very weak field permanently. And we have seen the very beneficial effects of this curing autism. So please don't put information you don't have any sure confirmation of.
So I told, and it stays valid, that you apply plasma waters, you apply GANs, and you apply patches where is needed and as long as needed. So autism is a special case. Not everybody has autism. The question was not referred to autism, it was referred to generally.
I think to avoid any further confusion as to which method and which not to use or to use, we will leave that for the discussion with Dr. Rodrigo, and I will then especially ask him to go through the different methods that one can use so that we can all learn from Dr. Rodrigo.
Very good, and I add here only that you can decide what to use and when to use depending case to case. So every case is different.
Yeah. Okay, thank you everybody. We'll call it a day for this week, and then we'll see you again next week.
Yes,
thank you Flint and Rick and Sandor. Thank you very much.
Thank you for being invited. And having this wonderful series of understanding the basics of plasma technologies.
Yes, thank you, everyone. So this is the Cash Foundation Spaceship Institute Public Teaching in English for Monday, November 6th, 2017, the 7th part of Understanding Plasma Science. Thank you all for coming, and we'll see you next week, same time, same place for part 8. And also tomorrow afternoon, 4 p.m. Central European Time is our 16th One Nation, One Planet, One Race for World Peace meeting. See you then. I'll have a good rest of your afternoon, morning, or evening.
There's no sound, Flint.
Thank you.